All right. Hello. Good morning. What is up, Liz? Nice to see you this morning. Welcome to everyone. Sorry if that's super loud. Trying to adjust the microphone a little bit here. Okay. If for anyone who is new, if you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is a weekly live stream here on the Adafruit channel where I work on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it, I should say, at the main website for the project, circuitpython.org. The quick version is that this is a implementation of Python that runs on tiny computers. It is a fork of the MicroPython project, if you happen to have heard of that. The way that it works with CircuitPython typically is you will plug these little microcontroller devices like the ones we see here. You'll plug them into a computer with a USB cable. They show up like a thumb drive. You can edit a Python code file on that thumb drive, and when you save it, the microcontroller will execute the Python code for you. Will interpret and execute that Python code. The code itself can interact with whatever other peripherals you hook up to the microcontroller. So some devices like this top row of Raspberry Pi Picos, very generic. They don't really have anything built in. You have to add whatever you want it to do. Other devices like the Circuit Playgrounds, they are more purpose-built. These ones happen to be built around the purpose of education. So they have lots of sensors, 10 neopixels. They have alligator clips instead of like breadboards or anything like that. So very easy to connect more stuff. There's a speaker, I think maybe a microphone. There's IR input and output. Maybe no microphone. I'm not sure on the microphone. I don't remember all the things. I know there's lots of things on there, and there's also a Bluetooth one as well, which has slightly different capabilities, but is a similar form factor. But that is just to say that lots of these devices are very general. You add whatever you want. Other ones are more purpose-built. It's kind of built around a specific use case. You get it, you use it for that, and you can program it with CircuitPython. As always, we will say thank you to Adafruit. Adafruit is a hardware and software company based out of New York. They make CircuitPython possible by paying a team of folks to work on the project, including myself. So thank you, as always, to them. And if you'd like to help support me or CircuitPython or any of the other open source software that they pay people to work on, one of the easiest ways to do it is by purchasing hardware from them on their website, adafruit.com. You can get yourself microcontrollers. You can also get all sorts of add-ons, right? Bits and bobs, plugins, things to hook up to your microcontroller to build other fun and interesting projects with. There is also the Learn guide link here, so I will use that as a quick segue to say this week, the I2S microphones guide went live. So this is my newest guide for anyone interested in audio stuff. I2S microphones now supported in CircuitPython. And there is a guide here that shows a couple of different basic projects that use them. What is up, Royal Bengali, over on the YouTube? What is the Discord server? Discord is linked down below. Other way, though, actually, if I could do my mirror math in my head there. adafru.it/Discord is down sort of this way. I can't point outside of my little circle here, but it is down on the screen down there towards the bottom, adafru.it. We are in the live broadcast chat, which is where folks tend to hang out during the live streams. There are also CircuitPython development channel and help with CircuitPython channel, as well as loads of other stuff that's unrelated to CircuitPython directly, but still cool and in the maker world. So yeah, definitely encourage you to join us over there on the Discord. Yeah, so check out I2S Microphones Guide for anyone interested in that. And today, what I would like to work on sort of partially ties into the microphone stuff. What I would like to take a look at today is this thing that is in audiocore, but it's hidden behind a debug flag. You have to compile. Get to audiocore. You have to compile CircuitPython with this audiocore debug in order to get this function. But when you have this function, it's called getBuffer. You can pass in. They call it a sample here, but I think it's anything that functions with what I refer to as like the streaming protocol. So this is like synth.io. This is audio delays, audio speed, audio effects, any of those filter chain, effects chain modules that are in the core, like audio delays, filters, reverb, all of these things. I believe these all implement this like stream protocol, which means they can kind of like take input, send output. And if I understand correctly, what this get buffer does is it allows you to pass in any one of those objects that has that stream protocol, and then get the current data. Just get a block of data for, this is what data is currently in the buffer, or this is what data is currently in that streaming channel. And this is cool for a few reasons. We could write the data to the disk, which is one of the things that I have been working on lately is SDIO IO support for Raspberry Pi, which sped up the SD card writing, which allowed it to record in real time. This would be another sort of API that we could do the recording with. It would not fundamentally change what's possible. Well, that's not entirely true, actually. For recording from the microphone by itself, it wouldn't fundamentally change it. The new stuff that it would enable, though, is recording, like writing to a file from Synth.io. So if you want to generate your own music with Synth.io and then save that to a file, this would enable that. This would also enable stuff like audio reactive processing as part of your chain. So you generate audio with Synth.io, or you use the effects chains, and you could still get like audio reactive neopixels or FFT or something going as part of that chain. You still play the audio, but as part of that chain, you can get your reactive stuff without a microphone. This would be, by the way, this would be like as part of that chain. I know the microphone example exists as well. The other thing where this might come in handy, which actually I'll check in on this now because I meant to do this earlier and never did. Ooh, I don't know what form it was in. I may need to find this link again, actually. Dan linked me to this yesterday. Somebody posted, Kevin, I think it was KJW, Kevin James Walters? Kevin, I should stop guessing. I don't remember the exact, if it's James Walters or with the S's, I'm not sure what's where. Not opening for some reason. Walters, it is Kevin J. Walters. I don't know if it's actually James in the middle. I might have added that part. I don't know. KJW is more what I remember because I think that's where they were on Discord. This person made actually a really cool project, which was in the newsletter this week. So I encourage you to check that out. It was mentioned in the meeting as well on Monday. A little MIDI to CV. I don't actually know what this is where CV came up. Okay, I don't actually know what CV stands for. Control voltages. Okay, must be. You're at control voltages. So I'm very new to the audio stuff. So there's a lot of stuff where it's like seems like baseline, long-lived standards and stuff that I am just unaware of. Is that a single mega breadboard? Or maybe this is connecting to. This must be connecting to, right? It has to be connecting to. Okay. But in any case, Kevin was also asking here on the forums about a way to, the same thing we're talking about, to get the data, get a buffer out of the streaming protocol. In this case, they're using a DAC to generate audio, not a microphone, but it's the same idea, right? We want to be able to get this data out of the stream. So that's what this flag does. I'm going to make a build real fast with it. And we're going to try the SD card writing. If that's easy enough, then we'll try maybe NeoPixel stuff. But that's basically my goal for the stream, is just test this out. I saw this flag when I was working on either I2SN or SDIO IO, maybe before I really started, but as an experiment. Somewhere along the way in the last week or two, as I was working on this other stuff, I ran across this and I tested it briefly, but the thing I tested it on, basically it was an invalid test effectively. It was not going to work even if this thing had worked for other reasons. And so I'd like to go back, figure out what it does today, if it does all the things that I think it does, or if it can be used in all the ways that I think it can. And then if so, I think the next step is basically like swap the default for this, enable it by default, and then you can disable it if you don't need it, or we can go through and disable it on any boards where there's not enough room or something. While that is going, I'm going to take a peek at this. So I have this recording one. So the main difference here is this one is calling mic.record, which is a blocking synchronous record, I believe. Whereas the other way, the new thing that we want to add, I don't necessarily know that I don't think it blocks in the same way. I think it just gives you the data that was in the buffer. This is like starting right now, fill up a buffer of this size, one of these, I don't remember which one's the buffer, but fill up a buffer of this size with data starting now. And then it will record starting when you call this until it gets the amount of data you asked for. You can then write that amount of data out or do whatever you want with it. In this case, it's going to loop back around and call record again. The new one could just get this data out of the buffer. And so it kind of switches ever so slightly from start recording now and record this much data to give me the last, this much data from the recording stream. So it won't be like start now and get it. It'll just be like, give me the most recent data. Ever so slightly different. This did compile. I don't have the overhead camera set up today. There's really nothing, there's not gonna be anything to see because this is all just audio building, testing flags, seeing if it gets data out and such. Nothing to see, basically. Nothing to see here. Well, there's stuff to see, but everything to see is going to be in the terminal, essentially. Nothing visually to see on my desk, exactly. All right, I do have an unrelated example running right now. Something else I was testing. So I think we would, let me look at get buffer again. I think it, I'm not sure it's a drop-in replacement exactly. We might need, yeah, because this just takes the sample. One thing that does make this a little awkward to use, and something we should definitely add if we default, if we flop the default, right? If we enable it by default, we should add the doc strings for sure. Because right here it mentions no doc strings because it's like not, it's kind of hidden, not technically really there. And one thing I don't know is get buffer. Who chooses the size of the buffer in this? Seems like it just generates its own. Creates a tuple and returns it. Interesting. To start with, let's modify this down so it's not running quite so long. And let's just try calling that function and see if we get data. So here we have the mic enabled, and the mic is, in this case, I2S mic is one of these things that has get buffer. or that has the streaming protocol. So get buffer can be used on it. It's actually you pass it in, which means also we're going to need to import audiocore. Actually, I'm going to do from. Is it like that? Underscore between, right? Yeah, it should be. I think we could see it on here, even though it's not. Yeah, even though it's not in the doc strings. So it is odd. It is weird. It's going to be creating a new one every time, which sounds like garbage collection issue. So maybe in addition, we might want to remake it to be able to accept a buffer also and fill a pre-existing buffer instead of creating a new one and putting in a tuple. But let's just see what even comes out of it. So get buffer, and then we would give it the microphone. And we just get a memory view, so we're not able to really see the data either. But I think, so 1, what is the number? So this returns result 2. Is there a result 2? Yeah, so without doc strings, it's a little tricky to tell what it does exactly. I have to interpret the C code. It is passing a length here, but it is, well, it's passing an address of a length, but it is set to 0, so it's going to theoretically have some kind of special behavior for when it's 0. I mean, on the surface, I would think size makes sense, but it's a little odd that they were all 1 in that case. I don't see anywhere where result 0 gets set, which is odd. So like here we have result 2. Get buffer result. So this returns the int. I'm gonna need the definition. Sometimes control click would work for that, but I don't know. Buffer. Definitely structure holds the same string. Okay, audio core init C, sure. doc strings here either. This says returns proto.getBuffer, which is from an audio sample. Protocol audio sample. But raw sample is a type of one though, I think, not. Let us it will be able to trace the code and find out. In the meantime, I am curious if we can do something like check the length of memory view. Is that a thing? 256. So is that always data? Could we... What would I need to cast it as to be able to just see it? Like list works. And it is changing. Because it doesn't, well, it looks like it's oscillating actually. It seems like negative 5740. Yeah. Looks like it's just going back and forth. I would expect a bit more variation. Of course, I don't know if there's anything like moving it forwards. What does this say? Index 0 is the getBuffer result status code, which is the enum returned by getBuffer. It tells you the state of the sample's data stream at the moment you fetched it. Yeah, so we made it to here, and then I kind of didn't jump another one to find the actual definition here. So getBuffer is done. GetBuffer, so we are getting a lot of ones, which means more data is available. So I guess that means we could just keep calling it. So I suppose you would want to structure your code to check for 0 and then not call it again, right? So you would want to do something more like I'm going to say result or read status, result status, getBuffer result. Then we would get the status and the data. It is weird though, because we end up like one ahead or whatever. Say What was 2? Get buffer error. Yeah, so let's say while it's 1, get the buffer. So then we have data. So theoretically, we should be able to write that data Alright, so to use this function to get data instead of using the record function. And save this because I had extra stuff in there that was not relevant. Metro works. Nice. Oh, go. So I think it's not quite a drop-in replacement because the old code was reading a buffer of a specified size. The new code will need to handle the fact that get buffer seems to just return however much it wants. Usually, thus far, in only minimal testing so far, it seems like 256. Or it depends on the object, actually. It's saying it's get buffer. So each one has its own, but I think what we saw in this is each one has its own. It's actually just calling... Yeah, like a lot of these are all on different kinds of... In fact, I2SN is right here. Get buffer, it's actually, it looks to me like it's just calling through to the audio sample one, which is the one we saw. So I think these should all behave the same. But in terms of like if 256 is hard-coded or if 256 is coming from somewhere, then I think it's going to be the same for all of them. All the different things that provide that work for this get buffer, basically. Okay, yeah, and it is handling the status as well. And it gets rid of the raw buffer there we saw. So instead, it will get the data, it will get the status, it will check the status. It will break out with an exception instead of the while loop. There's how it checks the total samples. So it's very similar. That's one thing that's true. The sample, the streaming protocol thing is supporting, I think, only 8 and 16, whereas the I2SN mic itself does actually support higher. Bit depth 32 usually for 24-bit samples though. Yeah. Oop. So chunk size is now the half buffer, not a fixed size. And yeah, that's fine. Okay. Oh. I changed to 10, did not affect that, I wouldn't think. Going way too fast. I think there's nothing slowing it down to real time. So this loop is going until we reach total samples. But if we reach total samples, like there's nothing keeping us locked to real time. If we record, let's say it only takes us, half a second to write 1 second of audio, then we start the next second before the previous one is actually fully elapsed. Like we're ahead of time, and there's nothing keeping us back at the speed of real time. So you would almost need to I get buffer, won't interrupt, so it should never block. Check whether the stream buffer is allocated at construction. Output buffer is allocated only by reset buffer. Get buffer doesn't call it. Your previous run never called reset buffer, so output was null. I mean, we still have the same whole problem from above, do we not? It's not, nothing keeps us locked to real time. Null. Maybe it's also writing an empty buffer though, and then it's going much faster. Really ROM garbage. So it is updating. Okay, it is updating the Python code to call reset buffer first, and then presumably to have some kind of mechanism to slow down. Hmm. I wonder, do the other things have a record? So like, do the rest of the effects chains? Like audio speed or audio delays. Like one of these ones. Says play, playing, stop. Voices, delay, DNet. Interestingly, well, no, correct, because get buffer's not on this, right? Okay. Maybe. Maybe this will be good enough, but maybe there is also still a case for like the stream writer object. So this is kind of how I mentioned it during the meeting the other day. I was thinking of having one of these objects, not in audio delays, probably in a new module or in audiocore or somewhere, I don't know where exactly, but it would be one of these classes that implements the stream protocol. So it would be able to be stuck sort of at the end of the effects chain, or in the middle if you wanted, I suppose. And then it would be able to write data to the disk as you go. It would have to solve this problem, though, basically. We need pacing, essentially. Okay. It does at least not finish instantaneously anymore. Let's lower it and then see if it actually works. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We got close, 9.7 seconds. It will probably be a little bit wonky then. Not sure if we'll have gaps or anything else, any other sort of audio artifacts. Right. So SDIO, which is what I am using in this code to write to the disk, does not do the pass-through thing. Possibly it could be hooked up to. I did not look into that. Yeah, but for right now, it doesn't do it. So I think we need to, or there's still a few ways we could arrive at the same destination, but I think the easiest is just take the SD card out, plug it in this, and I believe this one makes talk. This is the older one that makes talk. So I think this is actually fine. I recovering this last time. I think it was empty, honestly. Okay. It's not silence and it's not super out of control. I've found it's fairly quiet by default. You can well, part of what this would enable is being able to go from the microphone through a an amp to get boosted volume, and then write the boosted one. I think y'all can't hear that, right? I don't want it to be too loud. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's sort of working, but it's not really, right? There's like you can almost even just see it in the waves there. There's like a choppiness, right? Testing 1, 2, 3, 4. Like an extra sort of playing card on the bicycle wheel spoke going on there. Okay. This may be just not quite the right tool for writing to the file. Let me look at the plan that I had here. The one thing I did put together the other day was this plan for, at the time I called it Wave Writer, but I think during the meeting I called it Stream Writer, but same idea in my mind. Let me see if this has anything about pacing. Driving the chain. Yeah. One thing I would say that this probably would be fine for is the audio reactive thing, maybe? I mean, I guess you'd still probably see the choppiness, I suppose. So this is non-blocking, and so yeah, this is just diagnosing the exact same thing we just saw. So the good thing, what I was looking for here, and what it does have, which is good, is it has a plan for why, like how this is going to solve the pacing problem. From C, lower. Okay. Okay. So I do think, yeah, I do think we will want a class for this, for writing to the file. And then I guess the next question becomes for the other usages like audio reactive and for this. So let me reread this again. So I've borrowed envelopes to make ESR outputs in this converter program. The detail is in this instructables. Okay. Oh, okay. Okay, yeah, this is okay, I see. So I mean this is basically like just mapping MIDI inputs to SynthIO sound outputs. And then it has a bunch of tunable knobs to change how it sounds. So your envelopes and all your different things here, and then ultimately outputs going to here. And then what they're saying is that they have to send the output to here, even though they don't really want to. They don't really have any reason otherwise to output it. So I gather they're not actually, like, probably these pins are not actually hooked up. But the problem is SynthIO will not produce anything unless you have a audio sync at the end of the chain, basically. You need that last link in the chain, all of which that currently exist are the audio outputs. You need that last link, otherwise the SynthIO won't actually make anything. And so what this would provide an alternative for that last link in the chain. This would give you StreamWriter or WaveWriter or whatever we call it. It would effectively take the place of audio out, and instead of writing to pins via some audio format, it will just write to the disk, the flash, whatever you pointed at. And I mean, I guess they probably won't want StreamWriter either, because they probably won't want to write to a file. And actually, get buffer is maybe not going to work for them either. Yeah, get buffer is maybe not going to work for them either, because if SynthIO still doesn't produce anything without the output at the end of the chain, get buffer's not going to act as that output, I don't think. So they would, I mean, almost they would want just like a dummy one, which is what they say, I guess, dummy audio. Where do they send the actual audio? Put it into... Is CV a thing that goes back out over USB? They get a mixer on the mixer, they play the mixer onto the dummy audio, and then they play the synth IO. They're calling silent synth on the first voice of the mixer. This is dot append. It does just call on, which in DAC, maybe the extra. Where does the MCP get initialized? Maybe it doesn't have a named class. Yeah, I don't know. I would have to trace the code a little bit more carefully, I think, to figure out where it is actually outputting to. Clearly not. Oh, here's okay. Here's our. Well, but these are just just enums. There it is. Okay, this is in the. No, it's not in the class. Down here. Okay. It's created and passed to DAC. Okay. But I think it's outputting into the MCP device, which is also, which is a DAC. Would be connected via whatever pins. So honestly, the weird thing maybe is that the code for this look like. I would almost say like this thing should be an audio sync. That's possible. Instead of like a dummy one that's hooked up to phantom outputs that you're not going to wire, or instead of creating a dummy one like a stream writer that doesn't actually write, that just acts as a sync. Maybe somehow we could make this object be able to be the sync. Maybe that's not at all how it works either, though, as noted. Still very new to the audio stuff. Hmm. I guess this does not. This could work for anything. It's not specific to audio, I guess. Okay. They're using it to output that CV. I see. Still maybe could be cool if you could wrap this in a thing that could be the audio sync, though, that could sit at the end of the chain, so that then instead of needing a dummy to get SynthIO to do something, you just need an output, even if your output is an existing audio out or is something more convoluted like this. I could see the case that that should just be the output instead of you needing the dummy in addition to also hooking it up in your own code to output via this thing. But in any case, I think let's keep looking back over this. I think this will be probably what I end up adding for writing the file. And then while I'm working on this, I'll be thinking about the other use case as well, where we are trying to route audio into a thing that's not technically seen as an audio sync. Maybe there could be a sync that just gives you like a get buffer function or something. Would you even need that? I mean, for KJW's post here, you wouldn't even need the get buffer, really. Oh, they do talk about asking to get a buffer? Okay, so it's kind of two questions or two topics essentially. They sort of intermingle, but it's like topic one is like get this thing to play without an audio sync, without an audio out instance, and then topic two is kind of like be able to do the graphical display thing, so thus be able to get data out of the chain that represents the current audio. And it could be two birds, one stone, because you could make a sync that gives you the get buffer thing. So you could have like a stream buffer. So I'm imagining stream writer writes to files. Stream buffer could be initialized, put into the effects chain similarly, but doesn't write to files and just has its own get buffer function, which lets you get raw data out of it. You could then use it for whatever you want. You could use it for sound reactive stuff. You could use it for visualizers, which I guess is kind of sort of the same thing, right? Sound reactive LEDs are just visualizers of the sound. You could do it on a display as well if you want, as long as your display can keep up. Yeah. Could possibly do other stuff with it as well. Some kind of analysis of the audio if you're not necessarily trying to just visualize it, but maybe you want to analyze it for other things like, I don't know, try to split out bird calls or something based on frequency. I could see some kind of like processing like that where you're like trying to filter or whatever. Okay. So I think we do need this. I am leaning towards stream writer instead of wave writer. Although I'm not sure I can articulate fully why, because I do intend for it to write wave files, just, I don't know. I feel like it should say what it's writing from instead of the file format it's writing to in the class name, I guess. But I think this will probably be something I work on next. And like I said, I will be kicking around in the back of my head this question, both of these questions really from Kevin. So I do actually not think the stream, now that I'm rereading all this and thinking about it and talking about it out loud, I do not think necessarily that the stream writer really solves the problem. That they're talking about. I mean, it solves it in that it would get Synthio to play, but it doesn't solve it in that they surely don't want to be writing a file. Like they not have enough flash to make it very big. They might not want an SD card. They might not want the file written anyway, just to get it to work. So I don't think it's the exact solution, but I think it gets close to the same idea. Maybe there's two different things to create here. One is the stream writer and one is the stream buffer, the stream data inspector allower. Probably not going to come up with a better name than buffer, but that is, I think, going to do it though for today's stream for me. Thank you everyone for watching along. As always, I will go back and try to say thanks to Adafruit for supporting the work that I do on CircuitPython. If you want to help support CircuitPython and a plethora of other open source software that Adafruit pays people to work on, one of the easiest ways to do it is purchase hardware from them at their website. Later on today, although I'm not 100% sure if JP is back this week. So the banner ad's running, so usually that's a good sign for yes. But I will say tentatively, I think JP was traveling last I knew, so I'm not 100% sure if he's back. Possibly later on today, though, 4 p.m. Eastern, 1 p.m. Pacific. If not today, then normally on Tuesdays. This is usually a weekly thing. I just happen to know that I think he was traveling recently, and I'm not sure if he's back. So if so, you can check in Tuesdays, 4 p.m. Eastern, 1 p.m. Pacific. Not only can you help support Adafruit and the open source software they support, you can get yourself a wonderful discount on whatever the product of the week is on Tuesdays during that live stream. That is going to do it for me. I do believe Scott's back to deep dive this week for Friday, so I think for me, I'm planning to start back up the Saturday streams over on my own channel, so I will be over there Saturday mornings, 10 a.m. Central Time. And then I will, of course, be here on Tuesdays on the Adafruit channel, also at 10 a.m. Central Time, which is 11 a.m. Eastern, 8 a.m. Pacific. Until next time, I will bid you farewell. I will say so long. Thanks for watching, and I will